Have you ever stopped to think about the science hidden in the things you use every single day? Welcome to the hidden science behind everyday things, where we'll pull back the curtain on the ordinary. The world around us is packed with scientific marvels, fundamental principles of physics and chemistry at play, even when we don't notice them. We're going to explore common household items and actions, from floating ice to making toast, and see the science that makes them work. Let's start with a simple question. Why does ice float in water? This isn't normal behavior for most substances when they change from liquid to solid. The key lies in water's unusual density. Liquid water is actually densest at about 4 degrees Celsius, not when it freezes. As water cools past 4 degrees Celsius, hydrogen bonds force the molecules into a rigid, open, crystalline structure, making ice less dense than the surrounding liquid water, which is why it floats. Next, let's talk about the non-stick pan, a culinary hero. What makes food glide right off the surface? The secret ingredient is polytetrafluoroethylene, or PTFE, commonly known by the brand name Teflon. PTFE has an incredibly low surface tension. This means it has weak attraction forces to other molecules, preventing food proteins and fats from sticking. Now, onto a modern appliance miracle, the self-cleaning oven. How does it eliminate baked-on grime without scrubbing? The process is called pyrolysis. The oven heats up to extremely high temperatures, often around 900 degrees Fahrenheit or 480 Celsius. At this intense heat, the chemical bonds in food residue break down, turning the organic material into ash and gaseous byproducts, essentially incinerating the mess. Look in a mirror. Why does it perfectly reflect your image? The answer lies in the physics of light. Mirrors rely on specular reflection. Unlike diffuse reflection on a rough surface, the ultra-smooth mirror surface reflects light rays at the exact same angle they strike it, preserving the image. The actual reflective surface is a microscopically thin layer of aluminum or silver applied to the back of the glass, protecting the delicate metal coating. Finally, let's look at a breakfast favorite, toast. What transforms soft bread into that golden brown, flavorful crunch? Two major chemical processes are at work. The Maillard reaction, which browns the proteins and sugars, and caramelization, which specifically browns the sugars. These reactions generate hundreds of new flavor and aroma compounds, giving toast its complex taste and its appealing golden color. From the ice in your drink to the toast on your plate, science is constantly happening right in front of you. We've seen principles like density, surface tension, pyrolysis, reflection, and chemical browning at work in the most common of scenarios. Now that you know the hidden science, take a moment to observe the fascinating processes unfolding around you every day. Thanks for watching.